My name is Leroy Harbach. I work for CMC Rescue. I'm one of the rescue school instructors, teach at a variety of different locations, and today we're here to talk about the MPD, the operation, and how to use it. So the MPD is designed to replace all of this traditional setup that you would typically find with the anchor plate, descent control, in this particular case a bar rack, the load release, change of direction pulley, and the prusik. Is all replaced by this one piece of equipment that'll effectively and efficiently do all of the same jobs that's done by this traditional setup. So the MPD is UL classified to the NFPA 1983 standard as a pulley, auxiliary equipment, as well as a descent control device. So it carries multiple certifications for one piece of equipment. The MPD comes in two different sizes. You have the 11mm version and the 13mm version. Both are designed to be used with static or low stretch kern mantle rope. To go over how it operates and the actual components, you have the release handle, which because there's no teeth and it's not jawed, it's a very smooth interface. We don't have to worry about rope damage. The secondary friction post is there as the rope would come up and through the backside to pick up additional friction for loads that are much heavier, to be able to lower them in a controlled fashion. And then the becket on the bottom is a rated connection point for either a forward tie or to take it and build mechanical advantage. So now we're going to cover how to load the device, connect it into the anchor, do safety check on it as well. First thing to remember is to make sure that the parking brake is in the off position. Turn the device over, and you want to follow the graphic. I like to refer to it as the load goes on the short side of the body as you look at it. So you rotate the cover plate open, put the rope over the top of the sheave, bring it down between the fixed friction and the movable brake, and close it. It's very critical that the rope is underneath where this bent flanger, this shoulder is, because that keeps the rope tracking over the top of the sheave. We're going to take it, connect it directly into our anchor, make sure that the carabiner is locked, and then give a sharp tug on the load side to make sure that rope doesn't peel through the device. It ensures that it's properly rigged and that the device locks up immediately. As soon as I put tension on it, the device should lock and nothing should happen when I pull. Okay, when to use and set the parking brake. If the operator would need to walk away from the device as they're setting up, either they're doing a changeover from a raising system to a lowering system or a lowering system to a raising system, you'd want to set the parking brake by turning it into the locked position. If I have a rope that's muddy or wet, I may need to actually lift up and turn the release handle in the clockwise position to get additional friction to be able to get it in a fully locked position. If the operator needed to walk away completely from the device and didn't have their hand on the rope, I'd want to close the system by bringing the running part over the top of the standing part of the rope and tie it off with an overhand. That universal sign that the system has been safetied off. To use the MPD as a descent control device, there are a few critical things that you really want to remember. First of all, you want to feed the rope from behind the device and your primary friction is actually at the fixed brake through the V groove on the back side. You want to maintain that nice S shape to the rope, and when we operate the release handle, we want to operate it fully open and use your backhand as your primary friction. At no point in time should the rope angle be less than 90 degrees as it approaches and goes into the back side of the device. To operate it, I want to start off with my hand back in this maximum friction position. Take the parking brake off. Rotate the handle clockwise initially without lifting up on it. Then I want to lift up on it and turn it into the maximum release position. And then by letting the rope move through your hand, makes for a nice smooth descent or a nice smooth lowering operation. If at any point in time I feel like I'm losing control of the load and I let go of the handle, the load will stop. If I find that I don't have enough friction, I can always take and rig the rope through the secondary friction post, which will give me the maximum amount of friction during that lowering operation. To use the MPD as a belay device, a couple of things that you want to remember is the hand should be in a neutral position, flat, and what we're trying to do is we're trying to eliminate the amount of slack between your hand and the load itself. The other key thing is that I want to stay even with or slightly ahead of my main lowering system. The idea is to feed the rope in so that it's unseated from the top of the sheave, and by keeping it unseated, I can actually keep up with my main lowering system. If something should happen, however, the device will still engage and stop the load from additional travel. Because the MPD has a high efficiency pulley built into it and also acts as a progress capture, makes our changeovers and building mechanical advantages very easy. So for a simple one-to-one mechanical advantage, just by pulling on this side of the rope, I can bring my load up. In order to generate mechanical advantage, I need to rig in moving pulleys. And so by connecting into the prusik cord and hooking up our pulley, create a simple 3-to-1 mechanical advantage, stretching the system out a little bit, simple 3-to-1 mechanical advantage to bring our load up. Now as the system collapses or as our haul team needs to reset, just by slacking in this side of the rope, MPD will grab it, hold it in place, and I can go ahead and stretch my system back out. If during my raising operation I find that a 3-to-1 mechanical advantage isn't enough, I can make a very quick changeover by moving my single pulley back to the becket, locking the carabiner, bringing the bight of rope forward, take my double pulley, connect that into the prusik cord, take my bight, rig one side plate, close the other side plate, and now I've got a 5-to-1 mechanical advantage to be able to continue my raising operation. So once we've successfully negotiated the edge, we can actually increase our level of safety by changing from a hand-tight belay to a shared tension system or a mirrored system. But there are a couple of things that we need to remember. Number one, got to make sure that our attendant has good control of the load and that he's in the fall line of the rope. By making that change and sharing the load between the two ropes, we actually bring our margins of safety or our levels of safety up a little bit. And it's a very simple maneuver to do. It would merely be changing hand position from feeding rope in to bringing this hand back, and then lifting up and opening up the brake while they continue to lower on the main line until the load is shared between the main and the belay. So what we're going to do is we're going to demonstrate converting from a hand-tight belay and a main line to a shared tension or a mirrored system on the lower. So as we start to lower, my hand position is I'm feeding in equal to or slightly ahead of the rate of descent of the main line. Okay, and what we're going to do is I'm going to convert to shared system. So I bring my hand up, open, and by being nearby each other so that we can actually see what each other is doing, and matching the speed of the tracer threads on the rope makes it very easy to try and equalize the tension on both ropes as much as possible. When operating the MPDs in a shared tension lowering system, it's critical that the approach angle of the rope be back behind the device. In case of a failure of either rope system, the remaining system will then catch the load by the operator letting go of the handle. By taking a single pulley and connect it into our prusik, rig the rope into it, and then by extending the system out, and when we get ready to actually start retrieving the load, we want to make sure the parking brake is off. And so now by bringing the rope in or hauling on them at the same rate of speed, we're actually trying to equalize or share the load between the two ropes at all times. For care and maintenance of the MPD, it's a very simple device to be able to maintain. After every use, you want to make sure that it's clean, there's no debris or dirt that actually gets in the device that may affect the operation. If there's ever an impact load that happens to it, you want to do an operational check on it. And if you notice significant damage to the device, it should automatically be retired from service. For more information about the MPD, visit cmcrescue.com.